Okay, the first thing we need to do is read the problem. And the problem for 1.4 is along a railroad cut. A bed has an apparent dip of 20 degrees in a direction of north 62 west. The bed strikes north 67 east. Using orthographic projection, find the true dip. So what we know is an apparent dip and the strike of the feature. And what we're after is the true dip. We're going to know the dip direction because it's going to be 90 degrees away from the strike. Okay, I started with the orthographic lines, that is the north-south and east-west lines, to get a frame of reference. And then I drew in the two known pieces of information. I happen to choose to run them through the origin. That's not absolutely necessary, but it's one way to do it. Starting with the apparent dip direction, that's a 298 section line going across from the upper left to the lower right. And then a strike of 67, or north 67 east, going across in the other direction. The other piece of information that we know is the apparent dip. The apparent dip isn't going to appear on a map, but if we folded that line across, in other words, use the apparent dip direction and use that as a fold line to bring our stuff that's into the earth up to the surface, we could just draw it on the surface. That's the orthographic part. Breaking out a protractor, I measured out a 20-degree angle and I put in a line that is 20 degrees away from our apparent dip direction. Because the apparent dip direction line is a fold line, any view that we want into the earth is just going to take us perpendicularly down it. So we draw in a perpendicular line from the apparent dip direction line to our 20-degree angular line. Doesn't matter where, choose any place, just make sure it's big enough that you can slap a ruler on and measure it. For this particular measurement, I got a D of 0.78 inches. Okay, the other piece of information we were given, not specifically, but is embedded in the problem, is the fact that the dip direction is always 90 degrees from the strike direction. I can easily put in a line that is perpendicular to our strike line, starting at the intersection from our right angle with the apparent dip direction, and moving it outward so it connects to a line that we can go to that is the point of our 20-degree angle. That's also a strike line because they're parallel to each other. If we move out from the intersection of the top triangle, if you will, the mapped triangle, this point right here, we can measure out along the strike line the same D that we measured for our first triangle. All we have to do now is complete our third triangle, drawing a straight line from point to the edge of our new D, which was 0.78 inches, and then measure that angle, and we have our answer. For this particular exercise, I got 24 degrees. Your answers might vary by a couple of degrees, and your D's will definitely vary depending on where you drew your triangles. But your final angle for the true dip, which I show as 24 degrees in this particular example, should be about the same as mine.